Welcome to the tutorial where I teach you how to control a servo with a thumbstick. And this is video game style control, which means I can slowly accelerate it or decelerate it. And when I let go of the thumbstick, it stays in position. This is not absolute positional control like maybe you've seen in a map function. And furthermore, if you understand the principles in here, then you can control a full robot with any sort of controller, PlayStation, Xbox, Nintendo. All the principles are the same. And I even wrote the code so that the overlap is better for you. So we're going to go through this one step at a time. First, how do you turn a servo? Then how do you turn a servo slowly? How do you read values coming from a potentiometer? How that's basically the same as reading the values coming from a thumbstick. And then finally, how do you combine all those worlds to achieve slow, gradual servo control? So let's do this. We're going to start with the basics of how to rotate a servo using an Arduino Uno. This also applies to an Arduino Nano, also applies to an ESP32, Raspberry Pis as well, although it depends if you're coding it in Python or through the Arduino platform. But anyway, let's get started. So you could take any hobby servo basically, as long as it's within a decent voltage range that can operate off 5 volts. There's another way to power it, which I'll cover in a second. But yeah, so typical to most hobby electronics, you're going to have 3 wires. A power, which is the red wire, a ground, which is typically black or brown, and then your signal line, which is typically white or yellow. And so we're going to do this extremely straightforward. We can use a breadboard, but I want to keep this as clear as possible. We're going to go our signal line, just going to connect the white wire to the white wire there, and we're going to connect it into our input pin 10 on the Arduino. And then ground, I'm going to connect to the ground, the black wire there. And you have a couple ground options on your Arduino. I'm just going to pick any one here, boom, into that one. And then now we're going to give it power, and that's our 5 volt line. So I'm going to go red wire in, and wires are going to slip out. By the way, jumpers, most of these jumpers are kind of very low quality wire. If you strip your own wire and use those, I recommend it. I've stripped some of these jumper wires before. The amount of wire inside of it is honestly like on the nano scale. It's incredible how thin and sparse it is, either with aluminum or copper. All right, so again, we're hooked up, hopefully now without things popping out. So again, I have my signal line going into 10, my red wire connected to 5 volt, and my black wire connected to ground. So now let's code it. So the first important thing is you need to download a servo library. So I'm going to go here to my library, and if I just look up servo, I already have mine installed. And here it is down here. So Adafruit PWM Servo Driver Library. I've already installed it. Make sure you install that first. That's absolutely necessary to make this work. So now our first step is we have to include that library. So we're going to type in hashtag include servo.h. So that's good. So now we are accessing the pre-written code that will run a servo. There's a lot more going behind the scenes, which involves putting out a specific PWM value and scaling that. We're not getting into that. This is basics. And so now we're going to make a servo object. Servo, we use the capital servo like I did here. And then we can create any name we want. I'll just call it robot servo. So it's any name you want to put here. Just whatever name you want to put here is the name you continuously use. And so now we're going to say robot servo.attach. And this is the pin it's connected to. In our case, it's connected to pin 10. And you know, if you connected it to pin 9 or pin 8, you just put 9 or 8 in there, etc. Now, we're going to leave it at that. And then now let's run the servo. So this is going to be really simple. We're going to say robot servo.write. And I'm going to put 10 degrees. I'm going to give it a small delay. delay it for 3 seconds, which is 3,000 milliseconds. And then we're going to go robot servo.write, and I'm going to write it to 170. Now you might ask, well, why did I go from 0 to 180? Some servos won't respond if you give it that full a range. I'm just going a safe range for my particular servo, but you could probably put 0 and 180 in there. Then we're going to put delay, and we're going to delay that and hold that position for 3 seconds as well. And so now I'm going to upload it to my servo. And by the way, when we're here, I'm going to close down my library. Make sure you have the right COM port selected and the right Arduino. In this case, we're using an Arduino Uno. Then I'm going to upload it. And I made an error. I'm missing a semicolon. So let's upload that. And let's see if we're working. So it's going to rotate to 10 degrees, 170 degrees, back and forth. Now I want to cover one other thing. You really shouldn't power large servos like the little MG90Ss. Those servos you can power directly from your Arduino. Larger ones you really shouldn't. So what you should do is you should bring an external power source. Now let me show you a basic way to use this, because there's a rookie mistake that I've made many times. And of course I'm going to accidentally unplug everything. So I'm going to give the power directly coming from my battery pack. Yeah. Okay, now the ground, really important thing. You might think, oh, I'll just connect the ground to my battery pack. No, everything literally needs a common ground. So whatever ground you're using on here has to be connected to the ground on the Arduino. If you don't do this for any bit of electronics, it will not work. So what I'm going to do is connect the ground from here to my ground on my battery pack. So now the grounds of my battery and my Arduino are shared. And now I'm going to take the ground from the servo and connect that directly to there. Okay, so my servo is grounded. My battery ground is connected to my Arduino ground. My 5 volts is flowing directly from my battery pack into my servo. And now finally, let's hook up the signal line to pin 10 again. And there you go, you can hear the difference. Right? It's clearly getting more power, and it's not really a voltage difference. The main limitation is the current limit that the Arduino is capable of outputting. Again, you really don't want to use the Arduino to output power to things, just logic. All right, next section. All right, next phase in our process, let's add some speed control to the servo and rotate it slowly through its full range of motion from 0 to 180. And by the way, notice I changed my wiring setup just to make it easier for you all to see, where I just have the servo wired directly to the Arduino. Again, I don't recommend that. Use an external power source as I showed earlier. Okay, so let's make some modifications to our original code here. I'm going to make some variables. The first variable I'm going to make is called degrees. And I'm going to set that equal to 90. And then the moment I upload the code, the servo will be set to its middle default position. And I'm using floats and not ints, because floats will give you more resolution, because if you don't know the difference, an integer is a whole number such as 0, 1, 5, negative 137, 434, but it is not 1.2 or 3.14159, etc., right? It is a integer. Okay, so now float degrees, float servo Excel. And notice one of the things I'm doing is I am using a style of coding called camelback, where I'm combining two words by capitalizing the first letter of the second word, just for readability's sake. Now let's add something else to this. We're gonna open up a connection to our serial monitor. And if you're not familiar, your serial monitor is a way for your computer to read the values coming directly from your Arduino. Okay, so let's do that. We're gonna go serial.begin. And we're gonna set that to 9600, a typical rate. And now finally, I'm gonna add just a small delay in the setup. That's often done just to make sure that your setup code has time to set up. All right, now I'm going to delete everything in my void loop. And now let's add some code. First of all, we're going to go robot servo dot write, and we're going to write the degrees to it. So the moment we run the code, it's going to put 90 degrees, right? It's going to take 90 degrees and plug it in here. And notice I spelled right incorrectly. Good for me. All right, there we go. Right. W-R-I-T-E. All right. Now, we're going to do the following. This is an interesting thing. We're going to say degrees plus equals servo Excel. Now, for those who are unfamiliar with how code works, in any of your loops, well, it loops continuously. It executes one line of code at a time from top to bottom. Then when it reaches the bottom, it goes back to the top and does it again. So what are we doing here? Well, notice I'm saying degrees is plus equals servo Excel. Well, servo Excel is set equal to 1. When I run this code, I'm taking the degree variable, which was 90, and I'm adding 1 to it. So it's going to take 90, add 1 to it, making it 91. So after it executes this line of code, it gets to the bottom of the loop, goes back to the top, and now 91 is plugged in there. And so now it's going to take the 91 and add 1 to it, becoming 92, and so forth and so on. And it's going to keep doing that forever, unless I tell it to stop. And of course, I don't want my servo to rotate beyond 180 degrees, nor do I want it to rotate beyond 0 degrees. So let's control for that. So I'm going to say if degrees is greater than or equal to 180, or my degrees are less than or equal to 0, let's do the following. I'm going to take my servo Excel variable and servo Excel and set it equal to the negative version of itself. So what does that mean? Well, basically it means if servo Excel was 1, it's going to change it to -1. If servo Excel was -1, it changes it equal to +1. So when it rotates all the way up to 180, it's going to stop adding 1 to it over and over with this line of code. Now it's going to start subtracting 1 to it over and over. And vice versa. When it hits all the way to 0 degrees, it was subtracting 1 over and over. But now when I run this line of code, it's going to turn that -1 into a +1. And rinse and repeat the cycle. So yeah, there we go. That's going to make it work. But just so you all can see what's going on with the values, I'm going to do this. We're going to say serial.print, and we're going to put out, in quotes, we're going to put out the text first. We're going to put out the servo Excel, and end that with a semicolon. And then let's do some copy pasta magic here. Save us some time. Pasta. And then now we're going to put out the servo Excel variable. By the way, mine was uncapitalized, so I got to make sure I use the proper name for my variable. And then now we're also going to put out the degrees. So I'm going to say degrees, and then we're going to put out the degree variable as well. Degrees. Delete that, and we're going to put ln. ln during your last line of serial.print means basically it's kind of like hitting enter. So it puts 1 bit of data on your serial monitor, another bit of data, then it hits enter so that when the cycle repeats, the new line of code appears underneath it. And let's also add a small delay. Otherwise, this is going to move so fast we won't see things. So I'm adding a delay of 100 milliseconds, which is 100 divided by 1,000 is 1/10 of a second. And that looks pretty good, except I spelled degrees wrong. Don't want to do that. Let's also put so again, this is just the text that shows up on this screen. So I'm going to put a little semicolon to make it simpler to read. I'm going to put a space here so there's space between our variables. And that all looks pretty good. So now let's upload this code. And it's still running the previous code. And here we go. I did it correctly. Hooray. So now, if you watch carefully, you can gradually see the servo rotating to one end. It hits the extreme. Maybe it hit 180 there. And now it's going to rotate all the way back the other way until it hits 0 degrees. And let's show you what's going on the serial monitor. So I'm going to go to Tools, open up Serial Monitor. It's going to pause a second, reset. And now you can see, take a look at the value. We're adding 1 to the degree over and over gradually until it hits 180. The second it hits 180, that servo Excel value flips from +1 to -1, And because I'm executing this line of code over and over, notice I'm always adding servo accel. So in the original case, I'm adding a positive one over and over, right? But if I'm adding a negative one over and over, well, that's the same thing as subtracting one over and over. And that's why it starts gradually diminishing the value. All right, next step. How do you read the values from a thumbstick? So when I say thumbstick, I'm referring to any thumbstick. And so this thumbstick I have here is just one I bought off Amazon or the Adafruit store. It's literally labeled Arduino thumbstick or Raspberry Pi thumbstick or ESP32 thumbstick. They all mean the same thing. And this is the exact same technology that's used in any video game controller. And that is unless you're a sweaty person like I am and you use a Hall effect, because they're way better. All right, so now let's do the following. First thing, I want you to save your previous code here because we're going to use some of that. So I'll just go File, Save As. I'll put this on my desktop and I'll just call this like Move Servo for now. Okay. Oh, that's right. In order to save it, you can't have spaces in your name. It has to be Move, not Space Servo, but Move _ Servo or Move Servo with camel case. Okay. So there it is, that's saved. That being said, now let's make a new sketch. Okay, so we're gonna just read the values that are coming from our thumbstick. But before I get to that, let me just teach you the basics of how this works. I'm gonna read the values that come from a potentiometer because a thumbstick, most of the classical thumbsticks anyway, are just two 10K potentiometers at right angles to one another. So they literally took this thing, shrunk it down in size, and plopped two of those in here, one on each axis. That's all this is. That's the magic. That's how the sausage is made, kids. That's it. Okay, so now let's wire this up. So we have positive. I'm going to put it on one of the ends. Doesn't matter. There's no polarity to a potentiometer, nor a resistor. So positive on one end. I'm just going to go into the 5 volts, and then it's going to come out immediately. And then we're going to go to the ground on the other end. And then I'm going to go to the signal. Now, important point with the signals, you're reading an analog signal. And that means that you can only use the analog in pins, which in the case of my Arduino Uno are A0 through A5. I'm just going to pick A0. And now let's plug this in. By the way, this is not a good way to wire a potentiometer. These things really will barely stick to this. But in any event, I'm going to take that A0 and connect it to the middle pin, and hopefully it stays put. I'm going to take my red and connect it to one of the ends, and then my black, my ground, and then connect it to the other end. Now again, much better way to do this. Maybe you already bought a potentiometer that actually has wires coming off of it. You'd plug them directly into the Arduino or a breadboard. Much more secure connection. I'm skeptical that this will work first try. We'll see. Okay, so now let's write our code. First step. Well, actually, the first thing is I'm going to say, where's my potentiometer connected? And so I'm going to use const int, which means it's an integer that never changes. And that is, well, where this thing's connected. And I'm going to call that the potentiometer pin, or pot pin for short, and that is connected to A0. So there we are. It's where it's physically connected to my Arduino. Now I'm going to make a variable to store the data coming from my potentiometer. I'm going to call that a float, and that's potvel. A float's kind of overkill in this case because it's only going to convert it to integers between 0 and 1023, but in any event, we'll use it this way. Now let's open up a connection to our serial monitor again. Serial.begin. I'm going to use 9600. And then now we're going to do the following. We're going to say potvel equals analog read pot pin. Okay, so what are we doing with this line of code? Well, that variable we created earlier, potvel, we're running a routine on it. And that's a pre-built line of code that's built into the Arduino. It's running an actual process. And that process is it's taking the voltage, the changing voltage that's coming from the potentiometer, running it through an analog to digital converter and converting that changing voltage from 0 to 5 to a value between 0 and 1023. So we're reading A0, analog reading it, and converting it to a number between 0 and 1023. Now let's put that value out on our screen so we can see it. So we're going to say serial.print. First, we're just going to put out the text. So I'll just say pot value. I'll put equals, pot value equals. And then serial.print, and we're going to print ln so we can hit enter each time. And then I'm just going to put the actual variable, pot val. And now, just so it's readable, we're going to put a small delay in here, a delay of 1/10 of a second. And that should be all good. And let's upload that. Let me make sure I'm connected. I am. Upload. Okay, let's go. Tools, serial monitor. And there we go. And by the way, make sure in your serial monitor you're set to 9600 baud. You might be on a different baud rate. This number here has to match this number here. It's usually better to use a faster speed, but I'm going with a very commonly used default speed. Now watch this. I'm going to turn my potentiometer and look what happens. As I change the potentiometer value, as I physically turn my knob, the potentiometer value on the screen correspondingly changes. Rotate it all the way down, goes to 0. I rotate it all the way up. It gradually takes a different value all the way up to 1023. All right, next stage. Instead of a potentiometer, I'm going to hook up a thumbstick and I'm going to do some basic math on my thumbstick to convert the scale. And when we get to using the controller, it'll become more clear why. So first step, I'm going to just disconnect the wires from the potentiometer and I'm just going to repeat it on the thumbstick. So there's a bunch of labels on here. One of them's labeled plus 5 volt. Well, guess what that connects to? 5 volts on the Arduino, boop. And then there's a ground, and I'm going to connect the ground on the Arduino to the ground on the thumbstick. Makes sense. And then finally, I have my signal, which was going into A0. So each one of these, you're going to see VRX and VRY and SW for switch. So one of them is obviously the X-axis of our thumbstick, and the other one's the Y-axis. So I'm just going to connect this to VRX. And then, of course, if you want to use the other axis, we connect it to that one too. All right, now we're wired up to work. So let's add a bit of code here. So I'm just going to close my serial monitor for now. All right, so let's go thumb val instead of pot val. And I'm just going to control C that, plop it in here, plop it in here, plop, plop. There we go. So nothing new here. I just changed the label from pot val to thumb val for thumbstick value. Now let's make another new variable. We're going to call this float thumb x. Now this stays the same, but we're going to do a little bit of math. We're going to say thumb x equals map. And we're going to map the thumb val. I'll explain more about what this is in a second, which scaled between 0 and 1023 to a new scale between -128 to 128. Now, what the heck is going on with this line of code here? Well, it's map takes a variable on one scale and converts it to another scale. So I'm going to change the thumb value, which scaled between 0 and 1023, and I'm going to convert that scale. Instead of going between 0 and 1023, it's now going to go between -128 and 128. And it's going to store that in a variable and display that in a variable called thumbx. And the reason I'm using that is because a lot of the values, a lot of your thumbsticks in video game controllers the middle point is a 0, and all the way to the left is usually actually -127. And then it goes all the way to the right at 128. So I'm changing it to a scale that's more typically seen on a video game controller. So this is hopefully more useful to you. Now, we're going to just do some more copy pasta here because let's be lazy about it. I'm going to Control C these two lines of code, Control V them. I'm going to get rid of print line. By the way, of course, if I'm going too fast, please feel free to pause it. I'm just trying to keep up with TikTok attention span. All right, now we're going to change this to thumb X. I'm going to put a space before it just to give my variables some space on the screen. And yeah, that looks pretty good. So let's, by the way, Control T to nice and neatly line things up. Ooh, what happened to my void setup? I screwed that up, clearly. All right, Control T again. No? Control T. Why would it do that? That makes no sense. Oh, because I was missing a semicolon there. There it is. Whew. By the way, that's the other reason Control T is your friend. Sometimes it inadvertently highlights typos. Okay, so now let's run this. Upload it. And done compiling. Okay, let's take a look. Oh look, I forgot to put, I put thumb value here. It should be thumb X. Let's upload that once more. Because notice it was displaying the same value twice. There we go. Now, let's take a look at this. You could see what's going on with my two scales here, right? The thumb value, which is not scaled, is still going between 0 and 1023, whereas my thumb X is scaling between negative 128 and 128. Let me show you what I mean. So I move it all the way to the left, and notice thumb value reads 0, but thumb X is negative 128. I'm going to let off of it a little bit. These thumbsticks aren't very good, but notice, okay, I see my thumb value changing, and my thumb X is slowly changing, and it's going to get to about 0 at negative 1 because this is not a perfectly centered thumbstick, nor is my scale. My scale is actually a little bit off, but don't worry about that. And now I'm going to move it all the way to the right gradually, and boop, boop, boop. There we go. It scales up to 128 if I let off of it a little bit. There, 117, you see the thumb value scale, and I let it all the way back to center. And so, yeah, all I've done is taken the thumbstick variable, done just a little bit of math on it, and you're going to see why I did that more in a second. All right, now it's time to connect everything together. So I've disconnected everything so that I could reconnect it all in front of you and be very clear about it. And by the way, take the previous code that we created, and I just saved that as, I called it read thumbstick. And I put that here on my desktop. So read underscore thumbstick, or read thumbstick with a capital T and camel case, just whatever is clear for you to read. All right, now, how to wire this up. So first step is, let's just connect all the grounds together. So I'm going to begin with my battery pack. I'm going to connect the ground, which is the black wire on there, to a position here on my breadboard. I'll put it here at the top. So my ground for my battery pack is going into this top row on my breadboard. If you're not familiar, the way a little breadboard works is everything in a row is electrically connected via a little metal bar behind the plastic piece. So everything in this row is electrically connected. So I'll take a wire here, plug it into the same row, and now I will plug it into the ground on my Arduino. So now the ground of my Arduino is connected to the ground of my battery. And so now let's hook up our components. I'm going to take a ground from there and connect it, maybe, I don't know if it's good, there we go. Ground it there into the ground of my servo, yay. And then lastly, I'm going to take the ground of my thumbstick, and plug that into the same row. So yay, they all have a common ground. So ground. Okay, now let's do the same thing for the 5 volts. I'm going to take the 5 volts, the positive coming out of my battery pack, boop, and connect that to a row in here. I'll connect it all the way to the bottom row so it's more clear. So now this row is powered. And I'm going to take the 5 volts, or the positive coming, the 5 volt meant to go into my servo, and connect it to the same row using the right wire, which is not what I did the first time. So boom to there, boom to there. Now, one little detail. This would work, but I want to be cleaner about it. Because I want a continuous perfect 5 volts, I'm not going to connect the 5 volt on my thumbstick to the same battery pack because it's not a regulated 5 volts. So instead, I'm going to connect the 5 volt of this, of my thumbstick, to the 5 volt coming out of my Arduino, because I know that's a regulated 5 volts. So 5 volts to there, to 5 volties on my thumbstick. Okay, now we just got to connect the signals. So we're going to do as we did prior. My signal on my servo, the white wire, I'm going to connect that, boom, in there, into pin 10. By the way, I did not mention this earlier, but whenever you're using a servo or any device that uses pulse width modulation, there's only certain pins that output PWM signals on your Arduino. Those are denoted by a little squiggly tilde on your Arduino. So only those pins are capable of running a servo properly. So in my case, it's pins 11, 10, 9, 6, 5, and 3 from the looks of it. Okay? Now, last thing, let's get the signal hooked up. So I'm going to hook up the signal, which is VRX or VRY, doesn't matter. One's just in a different plane. And I'm going to go where I was prior into a 0. I hope you can make sense of this bird's nest. I tried to be as clean as I possibly could, but as Einstein says, things should be made as simple as possible, but no simpler. All right, now let's write the code to make this all work. So, as discussed earlier, we have here a code to move the servo. So I'm going to put that over there, dock it there. Then I also have a code here to read the thumbstick. We're going to synthesize these two. All right, so again, in the spirit of being efficient and lazy, let's do some copy pasta work here. So I'm going to take all this stuff here, Control C, and Control V it here. So again, this is my stuff responsible for turning the servo. This is my stuff responsible for reading the thumbstick. Also, along with this, we're going to do one other thing. This servo Excel, I'm not going to set it equal to anything. I'm just going to put it here, and let's not give the degrees any initial value. So now we're going to do the following. We're first going to, let's take advantage of this. I'm going to copy this stuff from thumb val and thumb X, plop that in here, and then let's do a quick Control T. So again, right from the get-go, I'm reading the value coming from the pot pin, storing it in thumb val. I'm doing some math to it, converting it to a scale between -128 to 128, and storing that in thumb X. Now, the keen of you might be like, hey, wait a minute, he's doing an extra step here that he doesn't need to. I do get that. If you understand what I'm talking about, just understand I'm doing this for people who aren't too familiar with this, and if they hook it up to a PlayStation controller and they read values coming between -128 and 128, this is more intuitive for them. So let me explain. So I'm going to say servo Excel is going to be equal to thumb X divided by 128. All right, so what's going on here? I'm reading the value coming from the thumbstick. I'm converting that to a scale between -128 to 128, and then I'm taking that value and dividing it by 128. So what the heck is going on here? Well, I'm scaling a number that's going between 0 and 1023, between -1 to 1. And specifically, when it's in the middle, this will register about 0. When it's all the way to the left, it'll register up to -1. When it's all the way to the right, it'll register up to +1. And yeah, honestly, that should be about it. Let's run this. Right? I move it, and I am indeed moving the servo, but it's pretty darn slow. So what I can do is just a simple multiplier here. I'm going to put 10 times this thumb value in here. Let's go 5 times. 5 times this value. I'll upload it again, and I'll show you the value so it becomes a little bit more obvious what's going on here. So now, look, I move my thumbstick a little bit, and the servo moves a little bit. I move it more, turns more. Move it to the left, moves a little bit. Move it further to the left, turns more, right? So look, I have joystick I have basically video game style controls, specifically linear acceleration, applied to a servo. Now this is much different than like the tutorials I went through where like, there's absolute positional control. Wherever I move the thumbstick to is where the servo turns to. And if I release the thumbstick, the servo goes right back to center. That is not a practical way to control things. And there we have it. So if you have any questions on how this works, I did this relatively simply and efficiently just to, again, make sure this is accessible to everybody and useful. There's so many ways to make this better, but again, this is the fundamentals of how you can control a servo with a thumbstick using video game style controls. So any questions, comments, please make comments. Please ask questions. And if you want the video on how I achieved the same thing using the PlayStation controller, which is back here to control this here, I certainly can cover that. That's just going to be a lot more detail, but it is something I'm open for if you all want it. But I also figured most folks out there, that's getting a little too big scale. These are more things that are available to hobby roboticists. And so I just wanted to make this as accessible to as many people as possible. So yeah, let me know what any other topics you want me to cover in Arduino and robotics. I will also be releasing videos on the basics of coding a video game. All right. Thank you for your time. Take care.